So let's have our first problem. We have velocity and speed problem number 1. The speed of propagation of the action potential, an electrical signal in a nerve cell, depends inversely on the diameter of the axon or the nerve fiber. If the nerve cell connecting the spinal cord to your feet is 1.1 meter long and the nerve impulse speed is 18 meter per second, how long does it take for the nerve signal to travel this distance? Now, first we need to write the given. So we have here the given. The given is simply 1.1 meter long, and we have here 18 meter per second. So the 1.1 meter long, simply this is the distance, and this 18 meter per second, this is the speed. Now, what is being required? Required here is how long. So we are talking about time. Next, simply, what is our equation? Our equation, on the basic side, we have speed is equals to distance over time. Now, we are looking for time. So therefore, we could have time equals distance over speed. We could apply our algebra method, wherein we have to crisscross this T and S. But in reality, of course, this is the procedure. S equals to D over T. Mathematically, you have to multiply it both sides by T, and then therefore you could cancel it now, and then we have TS equals to D, and then therefore T is equals to D over S. So that is just the same. Okay, let me remove this. Derivation. Okay, so we proceed now to our solution. The solution, simply time equals 1.1 meter long as our distance divided by 18 meter per second. That's 1.1 divided by 18 meter per second. So the answer is around 0.061 seconds. Okay, so let us check how many significant figure. We have here 2 significant figure, then that is fine. So this is now our answer. Let's have our sample problem number 2. A football quarterback runs 15 meters straight down the playing field in 2.50 seconds. He is then hit and pushed 3 meters straight backward in 1.75 seconds. He breaks the tackle and runs straight forward another 21 meters in 5.20 seconds. Calculate his average velocity for letter A for each of the 3 intervals and letter B for the entire motion. Now, for this problem, let's try to identify the given. So the given here we have number 1, 15 meters straight down the playing field. So that is 15 meter. That is simply the x sub 1. 2.50 seconds. That is my first time. Now, take note that this one is 15 meters straight down. So therefore, This 15 meters straight down, if it's straight down, meaning to say 15 meter going ahead. So therefore, the sign for this is positive 15 meter. Next, he is then hit and push 3 meters straight backward. So we have here 3 meter. That would be our x sub 2. Now take note that we have here 3 meter straight backward. So the play goes backward. It's the opposite of the first one. So our sign here is negative 3 meter. And the time here is 1.75 seconds. That will be our time interval number 2. Next, he breaks the tackle and runs straight forward another, which is 21 meter. This is our third displacement. And then we have here 5.20 seconds as our time 3. Now, what is the required? So, first requirement for letter A, we have average velocity. Of the 3 intervals. So we can have the first interval, then we could have the second interval, then we could have the third interval, and letter B, still average velocity of the entire motion. So let's start for this. Our equation is simply velocity is equals to change in displacement over change in time. Okay, that's actually the same formula for average velocity. So let's go now with our solution. So we have here our solution A1. That would be average velocity number 1. That is simply 15 meter divided by 2.50 seconds. And then therefore the answer for that we have 6 meter per second. Now take note of the significant figure. We have all 3 significant figure here, so our final answer must be in 3 significant figure. So this will be our answer for A1, A, first question. How about for the second interval? We'll label it as A2. And then of course, still we have the same formula. We have here negative 3 meter divided by 1.75 seconds. And then therefore, our answer is simply negative 1.71 meter per second. So you just check the correct significant figure for this. But definitely on my answer, I have 3 significant figure. So this will be our answer for A2. Now, how about for A3? Still we have average velocity. And then we have here 21 meter divided by 5.20 seconds. And that is simply equivalent to 4.04 meter per second. So this will be our answer on our third interval. Now, how about for letter B? Let's try to answer letter B. Still we have the same formula that for letter B we have total displacement over total time. So we can simply write it as average velocity, B, that is displacement over total time. So how do we compute for this? Simply we have 15 meter, and then we have plus, or since that's negative, that is plus negative 3 meter, and then we have plus 21.0 meter divided by my total time, which is at first we have 2.50 seconds plus 1.75 seconds plus 5.20 seconds, and then therefore that is around 33 meter if you press it in your calculator, divided by 9.45 seconds, and that is simply around 3.49 meter per second. Of course, with a 3 significant figure. So this will be our answer for letter B. This is the average velocity of the entire motion. Next, we have acceleration problem number 1. A cheetah can accelerate from rest to a speed of 30 meters per second in 7 seconds. What is its acceleration? So the first thing that we need to do is to simply identify again the given. The given here we have 30 meters per second. That is the velocity. But what kind of velocity we have? This would be the final velocity. Now, take note that on our problem, a cheetah can accelerate from rest. So meaning to say, the initial velocity is 0 meter per second. And we have another variable here. We have 7.00 seconds, and that is the time. Now, what is the required? The required is simple, and that is its acceleration. Okay, acceleration. The symbol is letter A. And next, what is the equation? The equation is simply equivalent to acceleration, that is Vf minus Vi over time. So we have now our simple solution, which is acceleration, that is simply 30 meter per second minus 0 meter per second as our Vi divided by time, which is 7.00 seconds. Now, so what will be the answer for this? So that is acceleration is 4.29 meter per second square. Okay. And this will be our final answer. Let us check its significant digits. So we have 3 significant, 3 significant. So we don't have a problem. We have 3 significant figure. So this is the final answer. Now, what does it mean? That the cheetah can speed up to 4.29 meter per second per second. Now let's have our acceleration problem number 2. A commuter backs her car out of her garage with an acceleration of 1.40 meter per second square. Letter A, how long does it take her to reach a speed of 2 meter per second? And letter B, if she then brakes to a stop in 8.800 seconds, what is her deceleration? So, let's try to identify again the given. The given we have here That is 1.40 meter per second square. There's a clue that if it is a second square or meter per second square, that would be our acceleration. Next, we have here 2 meter per second. And this is the velocity. By the way, speed or velocity, that would be the same in this problem. So, we have here the other given. If she then brakes to a stop of 0.800 seconds, so this one is her time. Now, what is the required? There are two questions that are being required here. For letter A, we have how long does it take? So time to a speed of 2 meter per second. And letter B, we have here the deceleration. So brakes to stop. In 0.800 seconds. So now, what is our equation? Our equation here is simple, since we have here acceleration, that is simply v final minus v initial over time. Right? So, for letter A, we are required for time. Since for letter A, we are required for time, we could simply derive it, and that is simply time, that is Vf minus Vi over A. So, the case here is simply applied algebraically how to derive this equation. So, from here we have A is equals to Vf minus Vi over time. Since we are looking for time, we multiply both sides by time. We have 80, that is Vf minus Vi. And then, in order for us to compute, we have to divide both sides by A. And then therefore, as you can see, the time, that is Vf minus Vi over A. So, let me erase this first. So let's go now. So we have your time, that is Vf minus Vi. So the first thing here, we have 2 meter per second, which is a final velocity, minus the initial velocity, which is 0 meter per second. And the acceleration here, we have 0.800 seconds. Sorry. Our acceleration here is 1.40 meter per second square. And then, therefore, the time now is 1.43 seconds. Still, we are consistent with our significant figure. Next, how about for letter B? For letter B, we are asked if she then brakes to a stop in 0.800 seconds. So for letter B, we have here acceleration is equals to Vf minus Vi over T. Now, we have to take note, brake to stop. So the Vf here is simply 0. Okay, so let's now compute. Our equation is still the same. So we have here A is equals to Vf minus Vi over T. And then for our equation, that is 0 meter per second as our final velocity minus 2 meter per second over the total time, which is 0.800 seconds. And then therefore we have here, that is negative 2 divided by 0.800, negative 2.50 meter per second square. And this is our acceleration. Now this negative 2.50 meters square, you have to take note that this is deceleration. Okay, so meaning to say the change in velocity is slowing down.